Hey Team Electronics and Coding, here is some information that, along with the information about PWM, is going to be important for you to solve your next coding challenge. So let's get right to it. Okay, first off, some variables. You are familiar with the int type variable. This is a variable that stores integers, so whole numbers. This type of variable can change over the course of the sketch. So, for example, we've used this type of variable when we have created variables that store the state of a button or a switch. State is going to constantly switch from low to high, high to low, back and forth. So you want to use this type of variable when you have a whole number that is going to change over the course of the sketch. Constant int, is a type of variable that is constant. Oops. So over the course, it's a whole number. But over the course of the sketch, it's not going to change. And you're going to see it used in a sketch in class tomorrow. And you're going to see why constant int is a good choice as a variable that in the sketch, because it's not something that's going to change over the course of the sketch. Okay. Next off, control flow statements. So we have been looking at class a series of if statements that have different conditions in them. So an if statement is going to have a condition, or maybe a series of conditions within the parentheses. So for example, we might have A equals B. If the condition is true, then you execute the code block, whatever is within the parentheses. Sorry, not the parentheses, the curly braces below the if statement. If the condition is false, then you go right around the code block down to the next line of code. So far, our statements have just been if statements with a condition followed by another if statement. Another structure that you can use that can help simplify your code if you just want two different things to happen is called the if-else structure. So what happens here is that if this statement, if this condition here is false, then whatever is between the curly braces that follow the if statement will be executed. But if the condition is true, you will go around, maybe if the condition is true, you'll execute the code block, and then you'll go around the else statement. Maybe a better picture of it is over here. So you have an if condition contained within your parentheses. If the condition is true, then you execute the code block that's contained within following the if condition. If it's false, then you execute the code block that follows the else statement. And then they both meet up at the bottom where you continue on to the next line of code. Okay, logic that is pretty easy to understand, I believe. Okay, a slightly more complicated control flow statement is called the for loop. Okay, a for loop has it's not really a function, so it doesn't have arguments, but it has three pieces of information that you need to provide it in order for it to run. First of all, it needs an initial value. It needs a condition, and it needs an increment. Okay, so let's give it some initial values. So we create a variable, and we can say for I equals 0. So our initial value of our variable I is going to be 0. The condition is going to be I is less than 4. And the increment is going to be I plus plus. Now, this is shorthand for saying add 1 every loop. Another way we could say the same thing. We could say I equals I plus 1. If we wanted to add 10, we could say I equals I plus 10, or we could say I plus equals 10. So these two are equivalent statements, and these two are equivalent statements. Okay, but what does this actually mean? Okay, so we have an initial condition. Our initial condition, we said I is equal to 0. Or that's our initial value of I, sorry. And then the condition must be that I is less than 4. Now, there's a code block. So our initial value of I is 0, and 0 is less than 4. So the condition is true. So whatever is within the code block is going to happen. The for loop is going to run the code block, and there might be multiple lines of code here. And then when it reaches the end at this parenthesis, now we're going to add 1 to I. So I is now equal to 1. So we cycle back up here where we evaluate our condition again. I, 1, is less than 4. This is true. So now we're going to execute the code block again, whatever is within the curly braces here. Now our new value of I is equal to 2 when we increment it, because we've added 1 to 1. So it's 2. We get up here, we see that 2 is still less than 4. The condition is still true, so we execute the code block again. You are getting it. Now I is equal to 3. 3 is still less than 4. So we execute the code block again, and then we increment again. Now I is equal to 4. 4 is not less than 4. So the condition is false. And we continue on to the next line of code. Okay, so whatever follows the for loop will happen after the condition is deemed false. Okay, so that's a for loop. You're going to see it in a sketch tomorrow. And then the last new function that I want to introduce here is the delay function. The delay function takes one argument, and the argument is a time in milliseconds. 1,000 milliseconds is equal to 1 second. So this function stops the Arduino moving to the next line of code for the time specified in the argument. So if you write, for example, delay 500 somewhere in your code, when the Arduino reaches this line of code, it will pause for half a second before it proceeds to the next line of code. You're also going to see this delay function in your next sketch. Okay, that's all.